My name is Paul Wright. I'm the director of CITRIS. Thank you very much for coming today. This lunch is sponsored by the Infineon company, and it's being webcast as usual to our 3 other CITRIS campuses. Friday, September the 18th, we have our energy luncheon, which is coming up very soon. So do join us not only then for Wednesdays, but for Fridays, where we're featuring a large number of excellent speakers in energy. Today, a distinguished astrophysicist, Carl Pennypacker, is with us from the Berkeley Labs, and he's the principal investigator for this really fascinating project called Hands-on Universe. So Dr. Pennypacker has been a research astrophysicist for most of his life, having got his PhD from Harvard in 1978. And then his principal research area has been studying supernova and building techniques for their automated discovery. But in addition to that, we're getting onto the topic of today, which is this Hands-on Universe project, and he's joined by several of his colleagues to explain that and its impact on education. So please join me in giving a warm welcome to Carl and his colleagues.
Thank you. So, am I on now? Let's see. How about this? Is this?
I think you're on.
Yeah, it's good.
Oh, I see. We heard it first time. Hello, hello? 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 Okay, sorry. Hi, anyway, it's an honor to be here. Let me thank Paul and Yvette and Gary and Masood and Horstraw for being able to share these wonderful facilities with you. Just a little background. Much of my career has been spent trying to work on or being open to advances in computer and imaging technology, how those mesh, and then how those could produce science together. So, in fact, I'm honored, I'm humbled to be here and see a statue done by Carlos Secan, who is one of the faculty members here. He was actually one of the inventors of the charged coupled device. CCDs are what virtually all of modern astronomy is based on these days, and so we're kind of coming to a center here. So anyway, so I want to describe how some of this technology from research, how we've gotten together with very capable partners and some of our staff to take what we think is an emerging technology, games, where there's a lot of interest in nation and internationally game technology being used to help educate our children and adults. And this is somewhat of a clunky system, but the idea is that the girls create games. The girls we're working with right now, they create games and then share them with their peers and can help advance others. And we found just extraordinary engagement by the girls. We'll be joined later by Heather Vilhauer in the front here and Joe Bunnick. Also, Heather's from the Girl Scouts of Northern California. Joe works with me at LBL and Space Sciences Lab. And also I want to introduce Jean Fahey. Maybe you could wave your hand, Jean, from Girl Scouts of Northern California. She helped write this grant. We're the beneficiaries of a substantial, well, for me substantial, National Science Foundation grant to fund all this, and it's just been a fabulous run so far. First, a little more context. This year is International Year of Astronomy, which is a effort sanctioned by UNESCO, the International Astronomical Union, and the UN General Assembly has all agreed this is a great year for astronomy and astronomy education. I'll show a little video clip on this. And it celebrates the 400th anniversary of Galileo's first use of the optical telescope. Didn't have radio telescopes then. But anyway, so Galileo turned his telescope to the heavens and saw the moons of Jupiter, the crescent of Venus, craters on the moon, and one other thing. But anyway, these all were revolutionary discoveries that helped change our view of the universe and certainly our solar system. And that's going on right now. Let's see, so let me go back now, but I escape out and show you, whoops, stay escape there. Let's see, and let's see, it's the Untitled 3? Okay, here's just a little video on IY, a short little trailer. I have to hit play. Old hillbilly trick. We're kind of using this momentum to propel the international propagation.
For the eyes of the world, now look into space. World Fair for man. Mark, Diane, please, for man. There seems to be no difficulty in moving around this.
So nice heroic. So again, I think I just wanted to show you that there is an international movement for astronomy these days. Again, 100 some nations. People love it. I think that's what we're finding is that's part. It's not the total allure, but having that content of astronomy really helps drive kids together and gives them enthusiasm about the technology. Again, we couldn't have the game without the high power technology. We're not convinced we could have such good engagement without the content matter of the astronomy. So one story I tell, and I shouldn't go on too long, is we had our global Hands-On Universe meeting in southern Brazil recently, and one of the teachers from a poor town actually south of Rio de Janeiro had a student who worked really hard, a young woman worked really hard and won an astronomy prize. You know, she had put huge amounts of effort into her project. So I said, well, do you want a small telescope or do you want a digital camera? What would you like? I said, well, I like a mattress because I sleep on the floor, and mattress would be really, really nice prize. Anyway, but that kind of, a lot of the passion amongst our team is, in fact, to make this a global effort to share our things. I'm convinced we'll get that young woman making a game concerning her experiences and her projects. So again, that's ongoing. I think as we've talked, it's realized that young women are not adopting careers in computer science and engineering nor other types of sciences nearly at the rate we want to. And again, middle school seems to be that period when things drop off. In elementary school, many teachers report that most of their kids have innate curiosity and they're picking up and examining things. But in middle school, a lot of things kick in, the peers, culture, et cetera. So they really lose interest in that. So that's a really important time to get through to them. So, and that's partially why we were funded by the NSF. And I think our main goal is in fact to this sounds like this is a very technical term, to give the young women self-efficacy and self-confidence. That is, they feel they can go up to some have a technical goal, undertake things, do something, produce a product, and then share it. That's sort of what the system we want to build into their consciousness, which they have aspects of. I mean, they do PowerPoints and they're doing Word documents, but I think this is at one level higher of abstraction, also which can be used for other. I mean, again, can be used for teaching. In fact, part of our scheme is that our collaborators in Africa, we have Universe Quest projects going on in Kenya, pretty strong now, and are just ramping up and going into Uganda, Zambia, and Rwanda over the next 6 months. Again, I mentioned we have this fabulous team. The Girl Scouts have a very thorough, tested, proven program of getting girls interested in technology. Girls Go Tech from the Northern California Girl Scouts, and they've really, been, involved in every element of the leadership and development of the project. How to work with the girls, what works with the girls, et cetera. So this has been actually quite a very fruitful one. The Girls Go Tech program is always open to collaborations and has enjoyed collaborations in the past with the College of Engineering here. Okay, now Paul mentioned Hands-On Universe. This is where the bulk of my education has been in the last decade. We've trained a lot of teachers around the world, about 800 in the United States. There's been some hiatus with national funding, but that'll come back. Children seem to like it more than other sciences, and we have evidence that they consider a career. We're not sure how long it sticks, but compared to pre and post-test, when students who wouldn't consider a career in science and technology, before Hands-On Universe, after Hands-On Universe would consider it. So we're having some ideas it's working. There's terms in science education called inquiry, where you try to make science education as much like science as possible. Hands-On Universe, which brings, I should describe this, it brings digital images into classrooms through computers. In fact, has embodied a lot of what we want. So here's a little, sorry to swamp you with videos. Do I just click on this, Heather? Yes. Okay. Whoops. Did the wrong click. Am I going the wrong way, I think? Okay, now. There we go. That'll do it. This is before I apologize, this is before the invention of the internet. And I had a lot more hair when we started. It's PCs. The guy's saying this is CNN. I can do a real-time translation from noise. Seems like a little bandwidth issue here. This might be a 1 minute thing going into a 20-minute thing here.
Just click again, Carl, I think.
Okay, yeah, well, gee, I apologize. What this did, I think what was very interesting in this, it showed the telescopes, it showed image processing. But what was really nice was, in fact, a lot of the star pupils in here were young women. And they loved the image processing, they loved the astronomy images. So that gave us a hint, even 10 years ago, that we had something special here. So, okay. Anyway, so I guess that wraps up my section. We want to leave ample time for talk. We about 20 minutes into our, yeah. So now let me introduce Heather Vilhauer from Girl Scouts of Northern California. She's going to describe some of the Girls Go Tech activities.
Good afternoon. As Carl mentioned, I'm with Girl Scouts of Northern California. I'm the program manager for the Universe Quest program. One of the things that came out of Girl Scouts in the last decade or so is really an emphasis on teaching girls about science, technology, engineering, and math. And that's where our Girls Go Tech program comes in. We have opportunities for girls to participate in after-school programs. We have special events they can participate in. We bring in a lot of role models, so they have the opportunity to talk to college students, professors, people who are in the industries that they're interested in that relate to those fields. We also have several partners that we work with. We work with TechBridge, with Chabot Space and Science Center, organizations that can help further our goals of helping girls understand these skills. So we have a lot of different focus areas, and these are our focus areas for right now. They've changed as time has gone on. Right now our big focus is on astronomy, robotics, and then we have another program that focuses on green design, toy design, that type of thing. The big piece, though, of one of the big pieces is that we're doing Universe Quest. And so just a little bit about the program, and then I'm going to show you a quick clip from KGO, assuming it plays, that will give you an idea of what some of our girls have been doing. So Universe Quest is a 2-year after-school program. It's a Girl Scout interest troop. They meet 2 times a week for 2 hours each time. They are involved in field trips. During those 2-hour classes, they get not only astronomy, but they also get a piece of game development information, so they're actually building the game, which you'll see more of later. The astronomy piece of it is taught by, we have a retired physics teacher that's involved. We have a grad student from here at Berkeley that's also involved at one of our other sites. The girls also have role model talks, so we bring in people from the field, game development, astronomy, that can talk to the girls about opportunities in the field, things that they may not know about, careers they might not have thought about before. We also have family nights, which is a great opportunity to bring the families in to really take part in their daughter's education. So during family nights, they have astronomy activities. The girls help lead their parents through the activities, and then they also get an opportunity to showcase their games. And so that's one of the big things that we've discovered is they love showing off their games. We also have a week-long summer institute that the girls participate in. Our participants are currently from 2 middle schools. We have one in East Oakland and one in West Oakland. It's approximately 40 girls between the 2 sites. The girls are in grades 6 to 10. We have a couple of girls who have graduated from the middle school and are continuing on in the program. We also have girls, a lot of them are from lower socioeconomic areas. So that's been one of the challenges that we found is that they don't have the science background to start with, so we're starting from a very basic level. We're starting from the basic skills of math. At some of our schools, the girls are scoring within 20% of what they should be for proficiency at their grade level. So when we're talking about brightness of stars and things like that, we have to start back with number lines and negative numbers, positive numbers. The girls have no concept of that. So it's taking the math skills and integrating those as well with the astronomy piece of it. The curriculum includes 2 pieces. It's the astronomy and then the technology piece. The astronomy includes everything from basic night sky observation to what's in the deep space, what's in the universe, so that they have a general knowledge of astronomy when they're done with the program. Through all of that, we've interwoven information about technology. So they're learning image processing. They are learning about the game development. They're using a planetarium software, which is a free download so the girls can take it home, called Stellarium, where they can actually look and see what's up at night. And that's been a great opportunity for girls to go home after the program in the afternoon and show their parents what they've learned, or to go out at night and say, oh, this is what I saw, or this is what I learned about in class. Through all of this, though, that we've really been able to take the technology pieces and interweave the astronomy into it. The ultimate goal is the girls are building a game that can then be shared worldwide through the web to teach other kids about astronomy. So they're taking their astronomy knowledge and placing it into the game. And one of the things that we have is one of our collaborators is in Kenya, and she is, the girls will occasionally talk to her via Skype, and she's done a great job really inspiring the girls to be interested in astronomy. And this is a piece that KGO did for us at the beginning of the year, or at the end of last year.
East Bay School has become an interstellar testing ground for an innovative new idea to boost young girls' interest in science and technology. As ABC7's Teresa Garcia found out, at the ASA Academy, expanding minds is as simple as playing a game.
Oh, Venus is up. Exploring the planets and stars and turning some of the discoveries into an online game. It's a girls-only mission with a group of students from the ASA Academy in Oakland.
What sky is Sirius in now?
About a dozen girls from 6th through 12th grade have joined an after-school program called Universe Quest. They're learning about astronomy and building their own 3D immersive online game that centers around creating characters who explore the cosmos and answer questions along the way.
Our main goal is to get them
interested in careers in science and technology build their own self-confidence, see that there's a trajectory for them.
Carl Pennypacker, a UC Berkeley astrophysicist and program leader of Universe Quest, says girls, and especially those in the African American community, have been traditionally underrepresented in the pipeline to science and technology careers.
Some of the young women didn't know about NASA, we found. You know, so clearly there's some teachable moments here.
With the help of a $1.5 million 3-year grant from the National Science Foundation to UC Berkeley, Pennypacker is collaborating with the ASA Academy and the Girl Scouts. Right now, they're in the pilot stage at just this one school, and it's already engaging the girls.
I like it because I like looking in the sky at night.
With the astronomy that we learned the week, we're going to put that into the game.
Ruby Knight and Tiffany Farmer are two of the students helping build the online Universe Quest game.
Solarium is a program so that you could look like at the stars and see when different constellations and planets and nebulas are going to be up.
So how's the sky out there?
The girls are also using the internet to get some global guidance. They're able to connect, for example, with Susan Murabana, an educator and astronomer in Kenya.
Using astronomy, we try and engage the students.
She speaks on Skype with Tiffany and Ruby and is teaching them how to build galaxy images for the online game. Eventually, the Universe Quest game will be open to girls around the world to play and build upon, linking minds and hopefully swinging the door open wider to encourage a future in the fields of science and technology.
It brings me to tears at times to think how well it's working, how these young women, I think, are really seeing things they haven't seen before.
Teresa Garcia, ABC 7 News.
So that just gives you a little bit of an idea of what the program is really about. You heard from some of the girls involved in the program. The girls who were in the program last year are very interested in continuing this year. They're excited for the startup. They actually asked, we're starting about 2 weeks after school starts, and they're like, why aren't we starting the first week? Because they're ready to get going and get started on their games again and learning more of the astronomy piece of it. With that, I'm going to turn it over to Joe, who's going to talk a little bit more about the actual game and the educational pieces that have fallen in with the game.
All right, thank you, Heather. Hi, everybody. I'm Joe Bunnick. I work with Carl and everybody on the project, helping to implement some of the technology involved with what we're using in the classroom. It's a piece of software that is now it's becoming it's moving towards an open source project, but it's called Thinking Worlds is the name of the software that we are working with the developers of Thinking Worlds on, using their software with Universe Quest. So. 1 second, please. As I'm sure we all know that there's lots of benefits for gaming, that games can be very effective learning tools, and that they can, when we're used in a classroom or an educational setting, they can help to encourage students to become more active participants in their education. We can. It allows us to help have them articulate their subject matter knowledge in a way that allows them to work to meet a goal or a common team-based goal that lets them kind of synthesize the different aspects of the material that they're learning. So what the game is, the software is it's kind of a two-piece package of there's the playing interface where as the game player you experience the exploration of the 3D environment, and you solve tasks and collect data and collaborate with other characters in an environment. But there's also another half to the game. It's kind of there's the authoring half, and that's kind of the more important to our project side of things. It's the authoring context lets the girls create they work towards building a storyboard and a narrative line that they want to articulate in a game. And so by setting by spelling out a task approach to this, they can use the game to achieve the goals that that are meant to answer the questions of the topics that they're learning about. People wonder, is Thinking Worlds, is it just like Second Life? And no, not exactly right now. Second Life is kind of a virtual chat room where you get to collaborate far and wide with many people. Right now, Thinking Worlds is a kind of an authoring application where we set up situations that where the player is interacting with other characters and objects. Thinking Worlds, it promotes interaction among avatars and objects as a means for delivery of knowledge. It also, Thinking Worlds affords us the ability to rapidly, the girls can produce and publish their own games. So it lets them kind of scale up and build interactive environments where they can pull together multimedia elements like image, sound, and some of the astronomy images that they are collecting from telescopes and from their own observations, and also from the virtual telescope observatory, the Stellarium application that Heather mentioned. So Thinking Worlds is designed to deliver structured learning challenges that provide contextual feedback to individual learners. And it engages players to explore situations where they interact with characters and other information that's in their game. So Thinking Worlds is, right now they've been using it to make individual games, but we're in the process of, the next step will be for them to link up the games with one another in a more collaborative environment so that all the girls' nodes of games can be part of a common, larger game. I think it might be a good spot for me to show you actually a quick sample of one of the games that a girl from Universe Quest made back in the springtime. Now, so the nice thing about Thinking Worlds is that playing the games is fun, and they do love sharing it with each other and showing each other what they've made. But it's just it's really cute to see them thinking more about the authoring and the kind of the storyboard, or what goes into making a game, designing a game to be playable. The puzzle kind of solving challenges they get into that. So here, a girl named Amani made this wonderful game where she's set up kind of a whole, a task to collect some information about nebulas and learn about nebulas a little bit, and then share this with some of the scientist characters that she has in her game. And she's kind of set up this nice. She wrote up a nice kind of almost a poem and a bit of a riddle into the thing. So it's kind of it's very, very cute. So we're supposed to go look for some information to deliver to this professor. And in her game, she's provided a few characters that will give you some clues as to where to look. I'm looking for the alien friend. He was in here somewhere. He may have wandered off in the half an hour while the game has been sitting here. But I actually know where to find the image of the nebula that the professor would like to have. And so I'll just collect it. And it was really cute because the alien character had this whole little poetic riddle that he delivers about nebulas being, masses of dust. She obviously may have cribbed that from Wikipedia, but then she has some questions about. It's actually not Latin for dust, and I accidentally tapped to click, and I just happened to get that last question right. So I've actually collected excuse me. I actually have a bit of. I have a piece of media. I have a image of a nebula. That is the task that she has at this level of her game for me to complete, is to deliver that to the balding professor character, which may or may not resemble Carl. And actually, I do have the information for you, sir, and here we are. And so, completing various steps of her game. The beautiful thing is the pride that each girl has from authoring and the creation of a product that synthesizes the knowledge that they've been picking up from the astronomers and the researchers that they are meeting in the project. That's really the beautiful part about it. So the opportunities that Thinking Worlds allows us to have for our users is that they can interact with environments and characters, artifacts and objects that convey information, and they can use Thinking Worlds to deliver challenges to their peers in the formats of proven learning behaviors that are vetted by the learning scientists who collaborated on the construction of the Thinking World software, such as comprehension or evidence gathering, compare contrasting. All those types of scenarios can be built into a game. Thinking Worlds encourages development of a range of cognitive processes by synthesizing that piece of learning knowledge. And the authoring side of things, which is where we're trying to focus on having the girls make something to share with the peers, gives them the ability to actively, direct events towards the completion of a task with specific learning goals in mind. The girls design these tasks that range from simple knowledge acquisition, like about nebulas, to more complex challenges, like completing an image processing, developing a piece of, getting data out of getting a result out of a raw data set can be the type of task that we can, have them work through. Thinking Worlds, you can provide for a player of your game guidance and support to help further an understanding of their knowledge via a feedback mechanism. And that's like, once they've completed a task, the user can be provided with feedback on their task performance, suggested things to revisit, an opportunity to log the materials they've collected and the goals they've achieved in a workbook type of record, so that they can come back and continue to play games. They can have a record as a user of a game, and be prompted to carry out further research on a topic by effectively leveling up in the game. Once you've completed a task, then it's a logical puzzle solving thing. The first challenge off to second up, followed by subsequent challenges based on the outcome of a prior challenge. So if they need to revisit and learn more about how to find objects in the sky, it might suggest them to prompt them to go revisit some of that material, or they could, if they've mastered that, they can start looking for finding some objects in the virtual observatory software that we have, and that's kind of the nice thing about Thinking Worlds in our project, is that it's kind of it's a vehicle for them to express what they've learned from the several different directions that they're learning about astronomy, about multimedia and game design, and science and technology, and it gives them a central point to create something that wraps it up in one thing to share with their friends and their peers and other people peers they don't know in other schools here in Oakland or in Africa as well, and on the web as well. So it's just really a nice use of the software. So thank you. I think I'm going to turn back to Carl and some observations about what we are finding.
How's that?
Was this where we're transitioning?
Why don't you come up? Why don't you come up too?
Yeah, come on up. There's, I think we wanted to say that where we want to take the game in the fall. We want to expand the use of the game to include other, to better synthesize some of the web technologies that are out there, the telescopes and databases and such. But I think I thought that this was the slide we were transitioning, the lessons learned, and that's.
So one of the things that we've learned is that girls really like designing the little things. They had the opportunity this past spring to design their own avatars, and that was huge. If I had given them a month, 2 months to do that at every class, they would have been thrilled. I mean, cutting them short on that was not a good idea. They had a very difficult time envisioning the entire final game that they were seeing. They looked at it piece by piece, so it ended up being a very piecemeal type game when you look at the girls' games. They also, as we discovered, and we knew pretty quickly, was that they don't like having anyone lecture to them. They prefer us give them a handout that they can read and follow the directions on. It was amazing how quickly they'll follow directions on that, but not if we're talking. So that's one of the pieces that we figured out quite quickly. Girls are really proud of their games. They're very, very engaged when they're involved in the games and involved in the astronomy piece of the games. Their interest in science and technology has increased. The picture there is from our summer institute. We were out at the beach, and it was funny. It became an impromptu physics lesson about what it meant to balance. And right after that, we had several fall off the back because someone moved. So that was one of the things that we found worked out really well. As we move forward, we are expanding. We're expanding to another site in East Oakland in the fall. We have a scale-up planned for winter, spring to 3 different sites. We're also looking at what Girl Scouts are starting as virtual troops, so online opportunities for girls to participate who may be in other parts of the Bay Area or who may be in other parts of the world or the nation. We are also looking up for a national scale-up beginning next fall, and then international partners, as Carl mentioned, in Kenya and several other African and European areas. With that, I think we're ready for questions.
Well, see, how about just one? Let me just say one thing. Again, even though, in this environment, I feel like we have such a clunky authoring system, but the girls did love it. And it, just as an example, during one of our family nights, we brought in the families and the kids, and the girls would sit, they'd have a few minutes, and they'd go scurrying off, I'm gonna make a new game, and build some new activities in, and then show their parents the new game on that, which I thought was kind of extraordinary. They had gotten that level of confidence and excitement and enthusiasm, and in fact, then wanted to share it. So I'm kind of, again, based on both, anecdotal and, statistical data, I think there's a huge impetus for all of us to go forward. And again, I'm very eager to hear what you folks might say, comment or advise us on or question us about the game. But I think does that wrap this up? Mm-hmm. Anyway, so thank you very much.
Thank you.
Okay, take some questions.
Yeah, you have I think it's once a week that's free for school kids at the Academy of Sciences in San Francisco and Golden Gate Park with the planetarium. And that seems like it would be something that would interest
We actually did that this summer as part of our summer institute. We spent the entire day there and then the girls had the opportunity to participate in a behind-the-scenes tour of the planetarium. So they actually had the opportunity to go under the planetarium, talk to the graphic designers who were responsible for the actual planetarium show. The girls loved it, especially it really connected for the girls who were very interested in the graphic design piece of our program in terms of the game development. It allowed them to see how they can tie that astronomy piece in. So it worked out really well. We're definitely doing that again this year.
So there are a bunch of general purpose game building software systems for kids out in the world, like Alice and Scratch and Squeak. And I'm wondering why you felt it necessary to invent your own software and how you would compare yours with those others. And while I have the microphone, I like the sandwiches better than the burritos.
Well, go ahead.
We actually are, I don't think we're limiting the girls to, I have what, Mike? To using just Thinking World. We're also looking at Alice as well. Alice front loads more of a, the intention is to learn about object-oriented programming through creation of games. I think we were looking to get a more quick startup. I didn't show you the authoring tool for Thinking Worlds, but it's it's robust. It's also simple. It's an icon-based kind of tree link up, either in parallel or sequence, and set up logical conditions for based on event completion. It gives them, I think, they're able to get started a lot faster than with Alice. It's a matter of linking tiles, thinking about naming conventions, thinking about, outcomes for tasks that, it gets to what they could use in other programming situations, but for us, I think we just wanted to get them going faster. So, and this actually wasn't developed by us either. This is a project that was in the UK and used in the UK Northern Ireland schools. So this is existing material.
It is an existing gaming engine under Thinking Worlds, and we're adding in a few extra things, not starting the whole engine over. And again, it was kind of historical, our choices. But I think we stumbled on. I mean, it's working great. I think there's something going on with the lizard brain about the love of these environments. I mean, they just. I mean, in terms of attracting you into something nice, I think that provides some of their functionality and attraction appeal that we might not have gotten so quickly. So I think again, it's a pretty fast ramp into an immersive environment with some control. And again, not unlimited control, but some control of that, so it's kind of working.
Heather and the Girl Scouts did take them down to Sun, and they were exposed to Alice, and if they want to pursue that, they can actually work. We fully encourage it.
Did you have any more to say about Alice, or?
Yes, thank you very much. Deviating a little bit from the technical and back onto the fact that they're young women. And I wanted to ask about, what the significance of that is, the segregation of the learning population from young men, and whether that's, helpful. Do you take cognizance of that, and is that a kind of a sanctuary for them?
It is. In a lot of settings, especially in educational settings for middle and high schoolers, it's huge when you start separating it, and you really see the numbers in a lot of the studies that show that girls, especially in math and science classes, will do better in segregated classes than they would otherwise. From the Girl Scout perspective, we also put in a lot of the leadership and that piece of it that we also play into it with the safe haven for the girls to really be themselves, to learn about who they are and what they can be strong at, what they can be really good at, and really building that. It's interesting that you asked that, because I had a parent contact me last week about other opportunities for boys in the area. And so if anyone knows of any, I'm familiar with BAVAC, which does the game development piece, but there's no program that really combines the two. So that's the reasoning at this point.
Yeah, I mean, I think it's reasonably well known or experienced, at least in Hands of Universe, which is boys and girls. The teachers really had to go to, they had to be careful to make sure the mouse was shared, and the kind of the quicker boys would not monopolize things and stuff. So there are issues that I think again mitigate for a somewhat safe environment. And but again, this and the Girl Scouts, in fact, they are our target audience. In fact, they seem to be the most group that probably warrants the most attention right now. So that was sort of our focus for the girls.
Have you all thought about collaborating with Google on using some of their new educational tools, Google Earth or Google Moon and Google Mars?
I know that I personally have played with them a little bit and looked at them.
Yeah.
We do take the girls down to Google for Engineering Week, so we do have some contacts there. It's a little bit just getting started. We were using programs that had already been used in Hands-on Universe before, so that we didn't have to create new curriculum materials that went along with that.
Yeah, and we've been in contact with we've had meetings through, actually there's George Smoot is helping form a teachers academy at LBL, and there have been efforts to talk to Google about ways they could work. And I think there's a little bit of buzz about using some tools from, or some images from a new survey telescope by some of the people who developed Google Sky. So we're trying to figure out how to do this. I think I'd be curious to see if there's a group at Google who might be interested in some of the specific game stuff. I think a lot of their activity has been on survey of data and use of good data tools, the sky, the earth, Mars, et cetera. And this kind of other level, this abstracted level of games and cognition, all this stuff, we haven't broached them out. If you know of such parties, we'd love to talk to them.
Probably one last question, then we need to wrap this one up. So.
Okay. Well, there is a Google Sky and a Google various planets. Have you done anything to systematically structure the astronomical data other than what Google is doing, just to make it convivial for the girls?
Well, let's see it. I mean, I think it's fair to say that when we start off, we just start, images coming down, and what's this image? We're helping develop or improve image processing software that's evolved through the years. So you can open up a FITS file, that's our file format, and do image processing on it, and they learn what a nebula is, and so they start to build their own knowledge and skills about different types of objects with image processing. We have our own databases. There are, again, the Google Sky. Now, I'm a little unsure of your question. Did you?
I think you need to keep in mind that the girls most of them are coming in with very little to basic astronomy knowledge, and so it's teaching them the fundamentals. I think is the first steps of what the curriculum that you've developed is before getting into the deeper data sources. I mean, these things go amazingly deep. So
but they can use their own robotic telescopes and telescope we have access to get their own images. So they're starting to acquire data. Thank you.